Okay, another wee video on this example here. So, this is actually question 9 from the worksheet that I posted yesterday. I've just abbreviated the question a wee bit. So just to explain the diagram, we've got a rhombus. We have the point Q, which is -2, 4. We have the point R, which is 5, 8. Okay, first thing we have to do is we have to find the equation of QS. Now the good thing about having the diagram is we can see exactly what we're dealing with. So we know that QS should have a negative gradient. Same format, we're looking for a point, the gradient, and we're also looking for the equation. Point's easy, we're given it, it's -2, 4. Okay, the gradient, first thing we look for is 2 points in the line. We don't have 2 points, we don't know what S is, we don't know what the point of intersection between the two lines is, the two diagonals is, so we can't use y2 minus y1 over x2 minus x1. Another thing that we could possibly be looking for here is m equals tan theta. Again, there's no mention of the angle measured in the positive x direction, there's no mention of any angles, so that's also something that we can't use. So that only really leaves us with one option, which is m1 times m2 equals -1. Now, we are dealing with a rhombus here, so what that means is the diagonals meet at right angles. So although the word perpendicular isn't actually used, we do actually have the ability to use m1 times m2 equals -1. So all I'm going to do is I'm going to find the equation, find the gradient of PR, and then use that to find the gradient of QS. Now we've got the equation for PR, we don't need to find the gradient using any of the methods y2 minus y1 over x2 minus x1, m equals tan theta, or perpendicular gradients. We've got the equation, which is y equals 2x minus 2. That means the gradient of that line is 2. And again, m1 times m2 must equal -1. So we know that the gradient of the perpendicular bisector, again, just flipping this, inverting it and multiplying it by -1 gets me -1/2. Okay, so we've got the point, we've got the gradient, we just sub into y minus b, y minus 4 equals m times x minus a. Okay, went off the page there a wee bit. A few things to deal with here. We've got the take away the negative inside the bracket, just be very careful with that, and we've got the fraction outside. What I'm going to do to get rid of the fraction is multiply everything on the left and the right hand side by 2. Now we just need to be careful when we do that we make sure that everything on the left hand side is multiplied by 2, so you can see it becomes 2y take away 8. And again, we need to be careful with what that leaves us with on the right hand side. If I multiply the right hand side by 2, then this 2 here will cancel out. However, I'm still left with -1 on the top. So again, I still have to multiply into that second bracket, or that bracket, sorry, by -1. So I get 2y minus 8 equals -x take away 2. Okay, just sorting things out, collecting like terms and moving the letter terms across to the left-hand side, adding x to both sides, adding 8 to both sides. And again, I've talked about the check. Anytime you get an equation of a straight line and you can check it, please do. We've got a point that must lie on this line. So let's check that. 2 times 4 is 8. 8 take away 2 is 6. So the equation is true. So I know that this is almost certainly going to be the equation of the line QS. It's not a perfect check because I used that point to actually find the equation. However, like I said, it's as good as we can do with the information we've got. Okay then, so part B, find the coordinates of T. Now T, should mark this in the diagram, is the point of the intersection of the two straight lines. I'll move this across a wee bit here. So let's look at the solution for B. Right, if I look at the format that I've got PR in, it's y equals 2x take away 2. I've got a letter on its own equals something involving x. I can use simultaneous equations. Well, I am going to use simultaneous equations, but I can use the process of elimination, or I can use the process of substitution. If you have a letter on its own equals something in terms of another letter, then you can use substitution. You don't always have to use elimination. So I'm going to go with substitution. So I'm going to sub y equals 2x minus 2 into 2y plus x equals 6. So So let's just see what that gives me. So putting into this one here, so my y is going to change from y to 2x minus 2. So it's going to be 2 times 2x minus 2. Again, just replacing the y with the 2x minus 2 plus x equals 6. Okay, so we get 4x minus 4. Add on x equals 6. Collecting like terms. And we get x equals 2. Now I talk about the diagram. We've got the diagram, so let's use it. Again, t, could the x coordinate of t be 2? Yes, it could, because it's in the first quadrant. So we're looking for a positive x coordinate. We're also looking for a positive y coordinate, if we've done this correctly. Use the diagram. Does the diagram back up what the maths you're doing? Okay, and then to find what the y coordinate is, again, we can choose either one of these equations. This one is y equals something in terms of x, so it would make more sense to use this one. Okay, so we're going to have when x equals 2, y equals 2 times 2, take away 2. So we get 4 minus 2. So we get a y coordinate of 2. Could the y coordinate of t be 2? Definitely. So it's actually asking for the coordinates of t. So we need to write them down. If we just write x equals 2, y equals 2, chances are at higher you would lose a mark. Okay, it's asked for the coordinates of t, so please make sure you answer the question. Okay, so let's double check that in the second equation. The second equation is 2y, 2 times the y coordinate, plus the x coordinate must equal 6. 2 times y, 2 times the 2 is 4, 4 add 2 is 6. So I know that that's correct. I know that that's correct. And it's also backed up by the diagram as well. Right, okay, so far it's the exact same as what we've done before. Part C is a wee bit different, and Part C is really kind of the reason that I've picked this example. So what we've got here is we've got the R is 5, 8. And what we've got to do is we've got to write down the coordinates of P. Now, there's a few ways to do this. You'll notice it's just saying write down. So it's not saying calculate. Calculate would give you the impression that you would have to find the equation, substitute into the equation to find out the coordinates b. It's just saying write down. And we can actually do this with the information we've got. So we know that this point here is 2, 2. This is called stepping out. Okay, and it comes into vectors, which is a higher maths as well. But it can come into straight line questions. So I know that that distance there is the exact same distance as that other half of the diagonal. So how I get from here to here is the exact same as how I get from here to here. So what I mean by that is if I look at the coordinates, R is 5, 8. T is 2, 2. So what I'm going to do is I'm going to look at the coordinates and I'm going to analyse how I get from R to T, because if I get from R to T, that's the exact same as how I'm going to get from T to P. So hopefully you can see that I take away 3 from the X coordinate to get from 5 down to 2. And to get from 8 down to 2 to get the Y coordinate, I take away 6. So I'm just going to follow that pattern on, and that's going to give me what P is. I'm going to take away 3 from the X coordinate to get -1, and I am going to take away 6 from the Y coordinate, and that's going to get me -4. Now, again, does that tie in with the diagram? Could P be -1, -4? Yes, it could. And again, that's something that we should be looking for. We should be looking to see if it ties in with the diagram.